Hello everyone, thank you for being here. My name is Doreen. I'm a PhD candidate in Singapore University of Technology and Design, where I work under the supervision of Professor Peter Ortner and Professor Lynette Chia, who are the co-authors in this paper with me. And this paper is titled The Frameworks for the Assessment of Flexibility and Adaptability in New Buildings. That is, the opportunities, the gaps, and the limitations that exist. Adaptability in the built environment is crucial because it allows the building to change in both function and form without big renovations. And in today's world where social, environmental, and technological factors are rapidly evolving, adaptable buildings are crucial because they offer long-term functionality, resilience, and sustainability. And a great example of this is the Key-Quarter Tower in Australia, which is seen here in the left, which embodies the principles of adaptability by allowing significant changes in both use and function with minimal reconstruction. On the right, we can also see different typologies possible as a good example of how we can repurpose or reuse space and the building itself in order to accommodate different uses that may arise in the future. So adaptability is generally defined as the ability of the building to allow change in function and form to accommodate these different uses and purposes in the future without the need for major renovation, demolition, or reconstruction. So as social, environmental, and technological changes accelerate, adaptable buildings really offer us several key benefits. And the first one is the functional and environmental benefits. So adaptable buildings limit the need for extensive renovation, demolition, or new construction. They adjust to different evolving conditions, helping to reduce environmental footprint, but also promoting sustainability. But it's also very benefitable in economic purposes because flexibility in design offers more cost-efficient approaches to managing current changes or future demands, and it helps to cater to evolving user requirements with minimal expense. It also beneficial in resilience because buildings with adaptable features are more resilient and able to respond to unexpected changes such as the shifts in occupants' needs, climate impacts, or regulatory updates. And this helps them to ensure long-term durability of these structures. Finally, we have social equity where adaptable buildings help ensure that the buildings can meet the diverse and the changing needs of different users, also prioritizing inclusivity, accessibility, and the safety for occupants of all ages, abilities, and socioeconomic backgrounds. So we can see on the right that embedding adaptability creates a circular flow of materials, enabling reprocessing, recycling, reusing, and repurposing. But there is a significance in assessing how much impact we are actually creating by embedding adaptability in our designs. And this is why this paper explores the importance of assessing flexible and adaptable building designs, particularly in new buildings, but also what are the current available frameworks and what are the opportunities, gaps, and limitations that exist in assessing the flexibility and adaptability of buildings in the context of building structures. And assessment is important because comprehensive assessment frameworks will enable the creation of buildings that not only meet today's demands, but are also accommodate the future needs as well. The methodology of this paper involved grouping different frameworks and assessing the ability to measure different categories, and I'll discuss this further in the next slides. The main aim of this paper being to identify opportunities, gaps, and limitations of current tools of assessment of adaptability, particularly in new buildings, focus was made on three main criteria. And the first one is spatial flexibility. And this involves the ability of the tools to assess changes in layouts of the space and different functions of the space. But then the second criteria is deconstructibility, and this is the ease of the tools to assess how the building can easily dismantle or how it's easy to use to reuse or recycle the building components in the future. But also finally, the third criteria is the load bearing capacity, and this is the ability of the structure to handle changes in different loads in the future. So if we have a change in purpose, how can the building handle different loads in the future? And these tools were further categorized into two major categories, which is the qualitative category and the quantitative category. Over the years, researchers have come up with new frameworks and models to assess adaptability, and each framework is seen to have its own scope and its own methodology and weighting system. Some have focused on new buildings, while others have focused on existing buildings, and the typologies also differ from commercial, residential, heritage, and we see that a few are also trying to cater all typologies together. Now, in this paper, we assessed each framework with respective to three main criteria of building's flexibility, which are spatial flexibility, the constructability of the components, but also the flexibility of the load-bearing elements. Now, these criteria were selected with reference to our previous paper that was published in June 2024, this year, which had reviewed various aspects of adaptability, particularly emphasizing the need to focus on structural components of the building. So from this, we realized that most frameworks aren't efficient enough yet to assess particularly the structural adaptability of the whole building frame, but most are able to provide a generic assessment of buildings' adaptability either qualitatively or quantitatively. This is why in this paper going forward, I will share with you how this paper has grouped these frameworks into two major categories, that is qualitative tools and quantitative tools. Qualitative tools are tools that provide assessment based on qualitative criteria, for example, ratings that rely on expert judgment. And these three tools are the tools that are known currently to assess the flexibility of particularly new buildings. The first one is Flex 4.0, which uses performance indicators to assess adaptability. So each indicator is given an assigned value, for example, 1 for bad, and 4 for best, and the aggregated value is used to represent the assessment of the building's adaptability. And then we have AdaptStar, which is slightly similar to the Flex series method in a way that it uses 26 criteria that are addressing different factors, for example, the economic and social adaptability of the building. And the AdaptStar uses a scoring system which is used to determine this rating, and this is actually developed by using experienced architects to create an assigned value for the checklist developed. And then we have the learning buildings framework, which provides a systematic method for quantifying the building's adaptability by also aggregating different adaptability scores for individual building systems. And it tries to focus on 4 dimensions that are the layer separation, the loose fit, the long life, and the reduced uncertainty. And each system's adaptability score is determined based on several factors, including the likelihood of needing adaptation in the future, but also associated costs, and also the extent to which adaptability strategies are to be implemented. In order to calculate the design-based adaptability, which is the assessment score for the learning buildings framework, there are different scores that have to be calculated and weighed and then aggregated to this value. And these different scores are weighed according to their significance in contributing to the overall adaptability of the building. So again, we're relying on expert judgment here. And using the learning buildings framework, the design-based adaptability DBA, the value can be quantified with a mathematical equation that represents the mathematical expression of this concept. Now let's talk about the quantitative tools. Quantitative tools, on the other hand, they use systematic methodology that quantify adaptability by the use of metrics and calculations and models that evaluate or quantify adaptability in a precise manner. And one of the frameworks that uses quantitative methodologies is Adaptable Building Design, ABD, which identifies different uncertainties and uses mathematical models and real options analysis to determine when flexibility should be utilized. But also we have the SAGA method, which is the spatial assessment of generality and adaptability. And this one utilizes a combination of unweighted and weighted graphs to measure both the passive support for change, which is generality, and the active support for change, which is adaptability of a building's spatial layout. And then we have the reconstructability assessment score, which provides the systematic scoring for dismantling and recycling building components by calculating the deconstructability assessment score. In addition to calculating adaptability through the deconstructability assessment score, the DAS tool also offers a graph-based evaluation process where connectivity between components can further be explored to identify which options are more suitable. So whether it's more beneficial to recycle or to reuse or to dispose in that order, depending on their conditions. Both type of tools have their strength, and we can see that the qualitative tools excel in capturing context-specific information, so such as the user preferences, but also the environmental responsibility and other non-technical factors that are crucial for a comprehensive understanding of what adaptability is needed. But also they allow for expert judgment and subjective insights, which can highlight aspects that are purely numerical data might overlook. They are also accessible, and they can be used by someone who is a non-technical stakeholder who would like to assess the impact of their decisions. On the other hand, we can see that the strength of the quantitative tools lies in providing the systematic and objective evaluation through precise calculations and numerical metrics. And by directly involving the building design model and relying on the analysis results rather than subjective assumptions, these tools ensure consistency and also repeatability in their assessments. Both tools have gaps and limitations. We can see that for the qualitative tools, the first one is subjectivity. So the system for ratings makes the process less technical and more speculative and biased. And lack of quantitative metrics, they typically do not employ systematic quantification to measure adaptability, which results into less precise evaluation compared to design-based or the quantitative tools. But they also overlook the adaptability of structural components and the flexibility of load-bearing elements. And finally, they lack robust validation methods, raising concerns on their reliability and also their accuracy in different contexts. And without proper metric validation, it is challenging for us to actually trust if the assessment outcomes are actually reliable. But on the other hand, the applicability of different types of typologies is a big problem for the quantitative tools, because to validate the practical implementation of the method, further case studies will be needed that involve different typologies and the users that should be considered. But it also has a potential to overlook important human factors which also influence the building use and adaptation, and the sophisticated computation modeling may be inaccessible to people with limited expertise. But finally, people may actually struggle to account for different uncertainties and dynamic changes in the usage of the building and environmental conditions over time. And this kind of limitation can lead to overly deterministic assessments that do not adequately capture the complex and evolving nature of building adaptability. Looking ahead, two key areas stand out for future research. The first one is the evaluation of load-bearing capacities. There is a room for exploring the implications of the building elements' flexibility on overall structural integrity, to really understand how the flexibility of building components really influences load-bearing structural behavior and safety for both new and existing buildings. But there is also room for life cycle assessment and embodied carbon tracking, and this tells us that we have an opportunity to develop a system to calculate the amount of carbon savings that we expect or we gain by actually adapting adaptable building strategies, and how can we track this from the beginning of the life of the building to the end of its life. With that being said, the assessment of adaptability in buildings is really essential for ensuring that new structures can meet future demands. And while current frameworks really offer a solid starting point, there are significant gaps that must be addressed to improve the accuracy and relevance in the future. Thank you.